Hey class, today we're going to talk about the 4 types of molecular geometries or molecular shapes that we have to learn for this class. Give a little detail about each, show a real life molecule as well as the Lewis structure. First up, we're going to start with the most simple, which is linear. Linear, as you know, means line. And the molecule that we're going to talk about is carbon dioxide. Carbon dioxide, we got 1 carbon and 2 oxygens. Generally with the linear structure, we're going to have a central atom with 2 atoms on either side. So the central atom in this case is going to be carbon. And oxygen is going to be on both sides. Now, in order to achieve an octet, carbon needs to share 4 electrons, but it also needs to share its 4 valence electrons with the oxygens. So let's draw that like this. Carbon's going to share those 2 electrons and share those 2 electrons. That shows carbon's 4 valence electrons. Oxygen is going to share 2 with that carbon as well, but it still has to have its 6 valence electrons. So it's going to have 2 unshared pairs like that and like that. Now you can count 1, 2, 3, 4, 5, 6 valence for oxygens. 1, 2, 3, 4, 5, 6, and then 4 for carbon. Total 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. A total linear bond, easier represented like so. We know the shortcut, the double bond, and then we still have to draw those unshared pairs. So this is what gives us the linear shape. And an easier way to look at it is if you have this type of molecule. Centerpiece, 2 on the outside. Carbon dioxide just happens to be the best example of this. Secondly, we're going to look at trigonal planar. Trigonal meaning 3. Planar meaning flat. Because this one, just like linear, is 2-dimensional. The example we're going to look at is boron trifluoride. Now, with a triangle, you're going to have 3 things, 1 on each side, and we've got 3 fluorines. So it makes sense that the fluorine would be the triangle intersections or the triangle angles. And boron's going to be in the center. So there's boron. You've got a fluorine here, a fluorine here, and a fluorine here. Now, fluorine has 7 valence electrons, so it needs to share 1. Boron has 5, so it needs to share 3, which works out well. Boron's going to share 1 right here, 1 right here, 1 right here. It's also going to have an unshared pair. Okay, so there's its 5. Fluorine's going to share 1, 1, and 1. So now if you count, you've got 6, 7 from fluorine, 7 fluorine, 7 fluorine. Each with that shared electron makes 8. And if you count boron, 2, 4, 6, 8, he's got 8 as well. Now, the easier way to represent this is like so. And that's where you can see the triangle shape come in. And now we've got it completely represented correctly. The molecule shape, if you will, something like this. There's your trigonal planar. Flat, triangle shaped. Okay, let's go up one more level. Let's look at the next type. This type's called bent, and it's named that because it's bent, literally. And a great example of this is our buddy dihydrogen monoxide, or water. A bent formation is going to be just like a linear, but it's going to have unshared pairs that push those two side atoms down toward at an angle to cause that bend or that bending formation. So we have one oxygen, 2 hydrogen. Oxygen is going to be our central atom. So logically, you would think hydrogens would be on both sides, right? Well, that's true, but when hydrogen can only share 1 electron, so that makes hydrogen good, but oxygen only has 4 electrons. It's going to have 2 unshared pairs. Now, you would think one pair would go here, one pair would go here. That's not the case. In order to have the furthest or most pushed apart electrons they can, they're going to go on the same side and push this molecule down. So let's look at what it actually looks like. And that's like so. And if you remember back to our electron chapter, unshared pairs push harder than shared pairs. So that's why these angle those 2 hydrogens down into this bent formation. And if we were to draw that shorthand wise, it would be oxygen, single bond, hydrogens. And then our molecular shape is going to be central, and my artwork is amazing if you can't tell. This would be our bent formation. H2O is a great example of that. Also NH3, ammonia, that's a good example as well. Bent is bent because of those unshared pairs. Let's look at the last type. This is the most complex, but pretty simple to draw. And that's going to be tetrahedral. And the typical molecule that I use to show this is CH4, which is also known as methane. Now, just from the looks of it, tetra gives us an idea of 4, and we do happen to have 4 hydrogens. So it makes sense that those 4 hydrogens are going to compose 4 different parts of this molecule, with the carbon going to be in the center. So carbon, right there, he has 4 valence electrons to share. He's going to share 1 there, 1 there, 1 there, 1 there. Hydrogen needs to share 1 electron to have 2. We're going to put hydrogen on all 4 sides. One, 2, 3. Boom, just like that. Very organized, very easy, very neat. Hydrogen's got his 2 electrons, 2, 2, 2. You count up carbon, 2, 4, 6, 8. All the atoms are happy. An easy way to draw this with 4 single bonds. 1, 2, 3, 4. Hydrogen, 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 hydrogen. Now, the molecule shape, I can't really draw well for you because it's 3-dimensional. I'll show you approximately what it looks like, but you have to imagine these things being in 3D. So you've got your central atom, and then you've got you've got 4 offset atoms, or the hydrogens, sticking off, but they're going to separate as far as possible. So these 2 would be sticking out straight. This one would be sticking up. This one would be sticking down. I don't have the artistic ability to show that. But you can look it up online or in the notes. It might have a better picture as well. But just know tetrahedral, 4 sides around a central atom. Best example, methane. I hope this helps to clarify any questions you might have about VSEPR. As we move forward, these concepts, these terminologies should become more and more familiar, easier to deal with.